This is packet 7, page 4, questions 8 and 9. When we look at these graphs, we want to make sure that we are finding all the information properly and that we graph them according to what it states. So when I look at this graph here, I see that I have a horizontal shift and a vertical shift. So when I'm doing my coordinate points, I want to look at 4 being in the middle, and I want to go 2 units left and right of positive 4 so I can see some good points and what this curve is going to look like. I see a fraction, but it's an improper fraction. That means that it is going to be an exponential growth. It's going to move 4 units to the right and 5 units down. That being said, I need to find some good coordinates by putting my table together. I'm going to have 4 right here, 3 and 2, 5 and 6 for my x values. And I'm going to find my y values just by looking at this table. I plugged it into the graphing calculator accordingly, exactly the way that it was written. And I have 2, negative 4.56, 3, negative 4.33, 4, negative 4, 5, negative 3.5, and 6, negative 2.75. So I'm going to graph those coordinate points to the best of my abilities on this xy plane. So we have 2 and negative 4.56. 3, negative 4.33. 4, negative 4. 5, negative 3.5. And 6, negative 2.75. We can barely see this curve, but it is curving nonetheless. Negative 5 is going to be our asymptote, so we want to make sure that we approach the line but never cross over it. And just kind of do a little quick sketch. The asymptote comes from this number right here, negative 5. So I'm going to go ahead and put it in there and label it y equals negative 5. I'm going to fill in all the other information. Domain goes forever left and right. All these graphs have all real numbers as our domain. Range goes from negative 5 up to infinity. As x approaches infinity, it goes to the y value goes up to positive infinity as our maximum value, and our minimum value is going to be, it approaches negative 5. So it's going to approach this number right here, negative 5. The y-intercept is not shown in my table here, so I go back to my graph. I select this graph right here, or I can just arrow up 0, negative 4.8. That takes care of question 8. We go to question 9. This graph is going to have a reflection over the x-axis, stretch of 2, parent function is 4 raised to the x, and I have moved 2 units to the right. So that means with my xy table, 2 is going to be in the middle, followed by 1 and 0, 3 and 4. I'm going to find those coordinate points. The graph is very much a stretch. We can see that it increases in the negative directions very fast. So we have 0 and negative 0.125, 1 and negative 0.5, 2, negative 2, 3, negative 8, and then 4 gets me negative 32, which is off grid. So I'm going to make sure that when I graph it, I don't actually pass over that number by mistake. So I come back here, graph it to the best of our abilities, 0, negative 1.25, or 0, negative 0.125. So really close to there. Okay, 1 and negative half, 2, negative 2, 3, negative 8, and then I'm off the grid after that. I didn't move up or down, so I do not have a vertical shift. So that means my asymptote is going to be the x-axis, which is y equals 0. So my asymptote is that line right there. Domain, no matter if it opens up or down, it's still going to be negative infinity to positive infinity. My range is going to go from negative infinity, because it's arrowing down, it goes all the way up to my asymptote, which is 0. As x approaches infinity, that way the graph goes downward. So I'm going to say it approaches negative infinity for the minimum value. When x approaches negative infinity this direction, then I'm approaching 0. The y-intercept, 0, comma, negative 0.125. And they're coordinate points, so make sure that you write them as such. That takes care of the 2 questions.